Good day everyone, I am Jamaica Reed and together with my groupmates, we'll discuss non-parametric tests, particularly the Wilcoxon syndrome test. To begin with, let's differentiate first parametric and non-parametric tests. So when we talk about parametric tests, not only ang mga ginagamit if the information about the population parameter is completely known. Thus also, parametric test assumes that the data is normally distributed. Then ang parametric test, ang iyang level of measurement or scale of measurement kinabilang sa interval scale or ratio scale. When we talk about interval scale, doon siyang mga category na i-rank or order with na extends. Walang ratio scale, kinaagyan ko siya yung category na i-rank or order at distance and na choose your part. Ang ginagamit mag-measure yung mga parametric test is ang mean. So basically, it is more powerful than non-parametric. So example of parametric tests are independent sample t-tests, paired sample t-tests, one-way ANOVA can be used when we are dealing with parametric tests. On the other hand, let's talk about non-parametric test. Ang kanina parametric test is magamit natin siya if ever wala or gamay lang ang ato ang available information when it comes to population parameters. Tapos kani siya, ang iyang level of measurement or the scale of measurement kinabilang sa nominal or ordinal. When we say nominal, kay kaning nalang siya category and pag ordinal na siya category and naapon siya rank or order. Also, non-parametric test makes no assumption about the distribution of data. Di ba katong sa parametric test, kaya ang it assumes na the data is normal distributed, but ang kanina parametric test makes no assumption about the distribution of data. Basically, it's kind of like a less powerful than parametric test. And when dealing with non-parametric test, Union test, Wilcoxon syndrome test, critical Wallis test can be used. So right now, let's discuss what is Wilcoxon syndrome test. So Wilcoxon syndrome test, it is a non-parametric statistical hypothesis test used to compare two samples, matched samples or repeated measures on a single sample to assess whether the population mean ranks differ. Like for example, when it is paired with difference test. So that's the definition of Wilcoxon syndrome test. So now let's talk about the different assumptions of Wilcoxon syndrome test. So the first one is that the data are paired and come from the same population, which means that the difference between pairs are independent and identically distributed. And second, the second assumption is that each pair is chosen randomly and independently, meaning that there is no systematic difference between pairs. And the data are measured at least an interval scale when, as usual, when pair difference are calculated to perform tests.
At this point, I'm going to discuss on how to carry out or on how to perform Wilcoxon syndrome test. So we have here two cases in which case 1 are paired data. The first step is to state the null hypothesis. In this case, it is that the median difference, which is denoted by M, is equal to 0. In other words, it assumes that there is no significant difference between the two groups or conditions being compared. It is also important to note the alternative hypothesis, which is ang median difference is not equal to 0. Next, calculate each paired difference. So, the difference is equal to x minus y, where x and y are pairs of observations. Just like for example, ang x is 5, then ang y is 2. So we get the difference of 3. Next, we are going to rank the difference, ignoring the signs. So from smallest to largest. Ang pinakagamay mao'y rank 1, and ang pinakadako mao'y last rank. After we rank each observations, now, we are going to label each rank with its sign, according to the sign of difference. So, if ang rank 1 kina ay negative nga difference, then it would be a negative rank 1. Lastly, we have to calculate the test statistic, denoted by W. So, W plus is the sum of the ranks of the positive differences, and ang W negative is the sum of the ranks of the negative differences. And if we are going to check the total of W or test statistic, we can use this formula, n times n plus 1 divide 2, where ang n is the number of pairs of observations in the sample. Now, We are in case 2, which is dealing with ties. So there are two types of tied observations that may arise when using the Wilcoxon signed rank test. First, observations in the sample may be exactly equal to m. Ignore stock observations and adjust n accordingly. So if 0 ang difference, automatic ma-adjust ang ato ang number of observations, which is ang n. So for example, ang n is 16. Mahimo na siyang 15 since na may isa ka observation nga ang iyang difference is 0. We also have here 2 or more observations or differences may be equal. If so, average the ranks across the tied observations. If rank 10 and 11 have the same difference, then its rank will be the average 10.5. Ato rank kwaon ang average nila, so 10 plus 11 divide 2 is equal to 10.5. Now, let's proceed to our example. Test of hypothesis that there is no difference between the perceived quality of the two samples A and B. Use Wilcoxon match pairs test at 5% level of significance. Following data are given below. So mao ni siya ang atong data na gamiton. First thing to do is to state or define the null and alternative hypothesis. So from our example, ang atong null hypothesis is there is no difference between the perceived quality of the two samples. While ang atong alternative hypothesis is that there is difference between the perceived quality of the two samples.
Next step is to calculate the difference between paired observations. Calculate the differences between each pair of matched or paired observations. Discard pairs with a difference of 0 as they do not contribute to the test. So just like here sa atong example no na gikuha lang nato ang difference of each paired observations by subtracting the brand A from brand B. So we have here 73 minus 51 is equals to 22. So 22 ang atong difference sa pair 1. We're just going to follow this formula, the difference from pair 1 to pair 16, then tagsa-tagsaon nato sila. Next is the rank to the absolute differences. Rank the absolute values of the difference from smallest to largest. Assign ranks to the absolute differences, ignoring the signs of the original differences. As you can see sa atong example, no, ato lang gibutang ang absolute differences and then rank. Then to put the absolute values of each observations, kay kopyahon lang nato ang differences, but ignoring the signs. So katong mga negative nga differences kay mahimo to siyang positive. Pag-rank dayon na to, kaya ato lang i-assign ang rank from smallest to largest absolute difference. So, we have here the ranked one. I-pair na to siya sa number 12 since ang absolute difference niya is 1, which is mo ang pinakagamay among all of them. So, as you can see sa atong table no, na atay isa ka difference nga 0. So, in that case, adjust dayon na to ang atong number of observations from 16, mahimo na lang siyang 15. Aside sa 0, napod tayo makita na same difference, we have here the 2 and 4. Sa atong himo dili, ato lang siyang girang from 1 to 15. So, katong mga nagpariha o absolute difference, kay disregard ra nato siya, bali ang pinakauna nga 2 is rank 2, then the other 2 would be the rank 3. Same lang Japon sa 4. Ang una 4 is rank 4, then ang other is rank 5. Next, since natay nagtay mano, so the absolute difference is 2 and 4. Ato pa na siyang kuhaan o average nila. We have here the rank of absolute differences of 2, which is the rank 2 and 3. So we have to add them like 2 plus 3 divided by 2 is equals to 2.5. We have to do the same sa absolute difference of 4, in which mga ranks nila is 4 and 5. So 4 plus 5 divided by 2 is equals 4.5.
So now I am going to discuss the step 4. So in step 4, we are going to calculate the sum of ranks of positive differences and negative differences separately. So as Ms. Nova explained earlier, if naay magtied nga ranks, so kuha na ang average of those two ranks. And then kung unsay naa sa ranks with tied, mo gyapon na tong kapihon sa sign of ranks. Ang nakalahi lang is ilaang mga signs. So as you can see sa differences, there are values na negative signs. So, kapihon lang nato to ilang signs to their corresponding ranks. So, for the positive differences, we have 13 plus 2.5 plus 4.5 plus 11 plus 10 plus 12 plus 15 plus 8 plus 4.5 plus 14 plus 7. So ang result is 101.5 for the positive differences. For the negative differences, we have negative 6 plus negative 1 plus negative 9 plus negative 2.5. So our result is negative 18.5 for the negative differences. So after that, in step 5, we are going to calculate the test statistic, or denoted as capital letter W. So W is equal to mean 18.5 and 101.5. So since we are going to get the minimum value, so we are going to choose 18.5. And step 6, determine the critical value and make a decision. From the example, use Wilcoxon match pairs test at 5% level of significance. So, ang atong N is 15, and then sa alpha value is 0.05 kay 5% man. So, kung subayon nato ng 0.05 and 15 nato na N is, ang atong critical value is 25. So, before we can make a decision, there are things that we need to consider. So, if the test statistic is less than or equal to the critical value, reject the null hypothesis. Otherwise, if it is greater than the critical value, fail to reject the null hypothesis. So since the calculated value, 18.5, is less than the table value 25 of W at 5% level of significance, hence we reject the null hypothesis and concluded that there is difference between perceived quality of those two samples.
So what are the advantages of the Wilcoxon syndrome test? So the first one is the Wilcoxon syndrome test is a non-parametric test. The second one is that the test can be performed well even with small sample sizes. The third one is preserving the ordinal nature of the data. And the last is it can be applied to different types of data, including continuous, ordinal, and categorical data. So what are the disadvantages and limitations of the Wilcoxon syndrome test? So the Wilcoxon syndrome test is generally less powerful than the parametric test. So the test assumes that the distribution of the differences between paired observation is symmetric. The third one is specifically designed for paired or related samples. And the last one is it requires continuous data for accurate interpretations of the results. We are now in the application of the Wilcoxon syndrome test in agribusiness management. So it has 5 applications, namely before and after comparisons, yield comparisons, quality assessments, sensory evaluations, and consumer preference studies. So by utilizing the Wilcoxon syndrome test in agribusiness management, decision makers can make data-driven decisions, evaluate the effectiveness of interventions, assess product quality, and gain insights into consumer preference. Thank you.